There is a woman standing at the edge of the known world, not the edge of the planet. Ancient humans understood, in the practical navigational sense, that the world continued beyond what they had personally seen. The edge of the known world in the sense that matters most. The boundary between the landscape that the accumulated knowledge of her community has mapped in detail across generations of occupation, and the landscape that begins where that knowledge ends. The landscape where the specific water sources are not yet located, where the seasonal patterns of prey movement are not yet understood, where the ecological rhythms that allow confident navigation have not yet been decoded. Behind her is everything her community knows. The specific valley where the salmon run peaks in late summer. The ridge where the signal fire can be seen from 3 days' walk in every direction. The specific outcrop where the best napping flint is found. The network of relationships with neighboring communities that connects her group to a social fabric extending several days' travel in multiple directions. In front of her is something else. Not nothing. The landscape in front of her is clearly continuous with the landscape behind her. There are trees, there is a river visible in the middle distance, there are birds that she recognizes, and others that she does not. But the specific operationally useful knowledge that would let her navigate this landscape as confidently as the one she came from, that knowledge does not yet exist for her community, for anyone she has ever met. And she takes a step forward. This moment, multiplied across hundreds of thousands of years, across every major and minor geographic expansion that ancient humans made across the planet, is the fundamental unit of human exploration. Understanding it, understanding what drove it and what enabled it and what its consequences were, is understanding one of the most extraordinary achievements in the history of life on Earth. Because ancient humans explored the entire planet, on foot, across open ocean, through ice, without maps, without compasses, without any navigational technology beyond the accumulated knowledge in their own minds and the specific biological and cognitive capacities that evolution had built into those minds over millions of years. And the story of how they did it is remarkable. Let's start with the scale of what ancient humans actually accomplished, because without appreciating the scale, the story doesn't land with the weight it deserves. Modern Homo sapiens first appeared in Africa approximately 300,000 years ago. By approximately 50,000 years ago, our species was established in Europe and Asia. By approximately 65,000 years ago, our ancestors had crossed open ocean to reach Australia, the first confirmed open ocean crossing in the history of any hominin species. By approximately 15,000 years ago, ancient humans had crossed the Bering Land Bridge and begun the occupation of the Americas. By approximately 1,000 years ago, in the more recent ancient period, Polynesian navigators had reached virtually every inhabitable island in the Pacific Ocean, completing the human occupation of every major landmass and island chain on Earth. The full global colonization of the planet by a single species, starting from a single origin point in Africa, took approximately 300,000 years. During that period, our ancestors navigated deserts, crossed mountain ranges, survived Arctic winters, crossed open stretches of ocean that had never been crossed before, and established viable communities in environments ranging from tropical rainforest to frozen tundra to high-altitude plateaus. They did this without any communication technology, without any transportation technology beyond the water vessels they built themselves, and without any of the knowledge that their predecessors in those environments could have left them, because there were no predecessors. They were going first. The question of how is not rhetorical. It is genuinely interesting. Let's talk about what drove ancient humans to explore, because the why is as important as the how and is often overlooked in discussions that focus primarily on the technical achievements. The standard narrative of ancient human migration tends to frame exploration as a consequence of necessity. People moved because they were pushed by climate change, by resource depletion, by population pressure, by conflict with neighboring groups. These forces were real and played genuine roles in specific migration events. But they are insufficient as a complete explanation. Here is the problem with pure push factor explanations for ancient exploration. Most of the environments that ancient humans moved into were not obviously better than the environments they came from. The people who crossed from Asia into the Americas were not moving from a resource-depleted environment into an obviously superior one. They were moving from an already functioning ecosystem into a completely unknown one, with no advanced knowledge of what it contained or whether it could support them. The people who loaded into boats and navigated across open Pacific Ocean to islands they could not see were not responding to a resource crisis. They were making a deliberate choice to leave a functioning island community and search for new land in an ocean that, from their starting point, appeared to have nothing in it. These are not acts of desperation. These are acts of curiosity, of the specific human impulse toward novelty, toward the unknown, toward the horizon and what is beyond it, that appears to be a fundamental feature of human psychology rather than a contingent response to external pressure. The curiosity drive, the specific motivational state of interest in novel stimuli, in unexplored territory, in questions whose answers are not yet known, is well documented in human psychology and appears across all studied human cultures. In the ancient world, this curiosity drive was not a frivolous luxury. It had direct survival value in a species whose primary survival strategy was ecological flexibility, the ability to exploit a wider range of environments and resources than any competitor. A species that explores finds new resources, new routes, new refugia, new options. In the variable, often catastrophic ancient environment, having more options was genuinely adaptive. The ancient explorer was not an anomaly or an eccentric. They were the expression of a specifically adaptive human trait, doing something that their psychology was built to motivate and that their community's survival benefited from. Let's talk about the specific cognitive tools that made ancient exploration possible, because the cognitive demands of navigating unknown territory are substantial, and ancient humans met them with capabilities that deserve specific attention. Navigation in the ancient world was a cognitive activity of the highest order. Without maps, without compasses, without any external reference system beyond what the natural world provided, ancient navigators maintained continuous awareness of their position in space through a combination of cognitive mapping, environmental reading, and the specific kinds of systematic observation that allow reliable inference about location and direction. Dead reckoning, the systematic tracking of direction traveled, distance covered, and elapsed time to maintain a running estimate of current position relative to a known starting point, is the foundational navigational technique available without external references. It requires continuous attention to direction indicators, sun position, star position, prevailing wind, magnetic field in some traditional navigational contexts, continuous estimation of speed and distance covered, and the mathematical ability to integrate these observations into a current position estimate. Traditional navigators studied in ethnographic contexts, Pacific Island navigators being the most extensively documented, demonstrate dead reckoning abilities that produce navigation accuracy across open ocean distances that modern practitioners using the same techniques and no instruments find extraordinarily challenging. Their accuracy reflects not just individual skill, but generational accumulation of systematic observational knowledge. Knowledge of star patterns, of swell directions, of cloud formations over specific islands, of biological indicators of land proximity, that was built up over many generations of systematic exploration and encoded in specific navigational traditions. The ancient humans who were making the earliest expansions across unfamiliar territory were not doing this with the accumulated systematic knowledge of established navigation traditions. They were building those traditions from scratch. The first people to cross the Bering Land Bridge were not following a known route. They were discovering that a route was possible, but they brought with them the same fundamental cognitive capabilities that later navigational traditions would develop into explicit systems. The ability to track position through dead reckoning, the ability to read environmental signals for directional information, the ability to build and update mental maps through systematic observation. Let's talk about the specific environmental knowledge that made ancient exploration viable, because navigation tells you where you are, but ecological knowledge tells you whether where you are can sustain you. The fundamental challenge of exploration is not getting somewhere new. It is getting somewhere new and surviving once you arrive. Any direction you can walk will eventually take you somewhere you have never been. The challenge is having enough knowledge and skill to find food, water, shelter, and protection from predators in an unfamiliar ecosystem. Ancient humans who were successful explorers were successful partly because the ecological knowledge they carried from familiar environments was transferable. The principles of ecological reasoning that allowed effective resource location in known territory, how to read terrain for water sources, how to identify the ecological relationships between different plant and animal communities, how to assess environmental conditions for shelter quality and safety, were applicable in unfamiliar territories even when the specific species and specific patterns were new. An ancient explorer encountering a new ecosystem did not encounter it as a blank slate. They encountered it with a powerful ecological reasoning toolkit, built from years of careful observation in familiar environments that they could apply to the new ecosystem to generate functional hypotheses about where resources would be found and what the new landscape could provide. This is genuine expertise transfer. The difference between an experienced ancient explorer in an unfamiliar environment and a modern urbanized person in the same environment is not primarily the availability of specialized knowledge about that specific environment. It is the presence or absence of the ecological reasoning toolkit that allows effective learning about any environment from direct observation. The ancient explorer was deploying this toolkit in real time, learning the new ecosystem through the process of moving through it, building the new map while navigating it. Let's talk about the ocean crossings, because they are the most technically demanding of the ancient exploration achievements and the most dramatic in their specific requirements. The crossing from mainland Southeast Asia to Australia, accomplished by ancient humans approximately 65,000 years ago, required open ocean navigation across a minimum of approximately 90 kilometers of water, with no land visible at the departure point. This was not an accidental drift. The specific currents of the region make accidental drift from Asia to Australia essentially impossible, and the genetic evidence shows a deliberate founder population colonization event rather than a gradual diffusion. Someone decided to cross that water. Someone built a vessel capable of the crossing. Someone navigated to a destination they could not see. This was the first confirmed open ocean crossing in hominin history. The technology required to accomplish it, some form of watercraft capable of ocean navigation, plus navigational techniques adequate for open water, had to have been developed before the crossing occurred, in a population that had never needed to cross open water of this scale before. What drove the development of ocean-going capability in an ancient population that was, at that point, nowhere near any body of water requiring it? The same curiosity drive and the same gradual capability building through shorter coastal and island-hopping voyages that the archaeological record documents in the period leading up to the major crossings. People who were exploring and fishing along coastlines and between visible islands were developing watercraft and navigational capabilities as a byproduct of shorter crossings, building gradually toward the capability for the longer one. The Polynesian expansion across the Pacific, which, in its fully developed form, represents perhaps the most extraordinary navigational achievement of any ancient human population, required navigational knowledge of extraordinary sophistication. Polynesian navigators used a system of positional knowledge that included star rising and setting positions, ocean swell direction, and pattern analysis, cloud formation behavior over islands, bird species, and their distance ranges from land, phosphorescence patterns in deep water versus coastal water, and the specific ways that ocean swells are modified by the presence of islands over the horizon in ways detectable through the motion of a vessel before any visual detection of land is possible. This system allowed navigators to maintain positional awareness across voyages of thousands of kilometers across open ocean, to navigate between islands separated by distances that exceed the visible horizon by orders of magnitude, and to return reliably to home islands from new discoveries to bring back the knowledge of new routes and new destinations. This was not guessing. This was systematic, empirically grounded, multi-generational accumulated navigational science, transmitted as cultural knowledge and deployed with the reliability that demonstrated results across many successful long voyages confirms. Let's talk about the social infrastructure of ancient exploration, because individual capability was not sufficient for the kind of exploration that ancient humans accomplished. Community structure and social organization were as important as individual skill. Exploration in the ancient world required community support. A small group venturing into unknown territory needed to be able to sustain itself through the transition period before the new territory was well enough known to be as productive as the territory they had come from. This transition period could be months or years. During that period, the exploring group needed sufficient number and skill diversity to manage all of the survival requirements of a functioning community: food acquisition, shelter construction, tool maintenance, medical care, child rearing, social cohesion, in an unfamiliar environment. The composition of an exploring group was therefore not random. It required a sufficient diversity of capabilities: hunters, gatherers with strong botanical knowledge, individuals with hide and clothing production skills, someone with fire management expertise, individuals with the social skills to manage the internal dynamics of a small group under sustained stress, to function as a viable community across the extended period of establishing themselves in new territory. The social relationships between the exploring group and the parent community from which they came also mattered. The ability to return to the parent community for resupply, information exchange, or genetic connection was a safety margin that made exploration less catastrophically risky. The specific social networks that ancient communities maintained, the long-distance exchange relationships that kept distant groups connected, were not just trade networks. They were exploration support infrastructure, providing the back connection that made venturing forward less existentially final than it would have been without them. Let me talk about something that is almost never discussed in the context of ancient exploration: the emotional experience of it. The ancient humans who were the first to walk into truly unknown territory were not automatons following programmed migration routes. They were people with the full range of human emotional experience, including the specific emotional states that the experience of genuine novelty and genuine uncertainty produce. Curiosity is a positive emotional state. It is energizing, forward-pulling, specifically associated with the anticipation of reward from new information. The specific quality of attention that curiosity produces, the heightened sensory alertness, the active processing of novel stimuli, the sustained engagement with the environment that novelty provokes, is exactly the cognitive state optimal for the rapid ecological learning that exploration requires. The emotional experience of curiosity was serving a functional purpose in the ancient explorer's cognitive life. But alongside curiosity was fear, genuine, rational, appropriate fear of the genuinely unknown. Ancient explorers in unfamiliar territory faced all of the normal survival risks of ancient life, plus the specific additional risk of not knowing where safe water was, not knowing the local predator community, not knowing which plant foods were edible and which were toxic, not knowing the weather patterns or seasonal dynamics of the new environment. This was real risk, producing real fear that had to be managed alongside the curiosity that drove the forward movement. The management of this fear, the maintenance of functional capability and clear thinking in the presence of genuine rational anxiety, is a psychological achievement that the ancient explorer accomplished every day of their exploration, and the community context of exploration was essential to this achievement. The shared fear, shared across a group of individuals who were all in the same uncertain situation, was collectively manageable in a way that individual fear in the same circumstances would not have been. The community was the courage as much as any individual characteristic. Here is something specific about the genetics that makes the ancient exploration story even more extraordinary. Modern genetic research has allowed scientists to reconstruct ancient human population movements with increasing precision, and the patterns revealed are consistently striking in their implications for the pace and organization of ancient exploration. The genetic evidence for the colonization of the Americas, for example, shows a founding population that was apparently quite small, a few hundred to perhaps a few thousand individuals crossing the Bering Land Bridge and then expanding to fill 2 continents within a few thousand years. The speed of this expansion, from the genetic evidence, was not the slow diffusion of a gradually expanding population. It was rapid, directed, and suggests active exploration rather than passive range expansion. The genetic signatures of ancient exploration bottlenecks, the specific reduction in genetic diversity that occurs when a small founding population establishes a new territory, are visible in modern populations worldwide. And they tell a consistent story of small, brave, specific groups of ancient humans making the crossings that eventually put human beings in every corner of the inhabited world. These were not statistical inevitabilities. They were specific decisions made by specific people to go somewhere new. Here is the full picture. The woman at the edge of the known world takes her step forward. She carries with her a toolkit of cognitive capabilities that millions of years of evolution have built specifically for this moment. The curiosity that motivates the step, the ecological reasoning that will make the new territory navigable, the dead reckoning that will keep her oriented, the social intelligence that will keep her group functional through the uncertainty ahead. She also carries everything her community has given her, the accumulated knowledge of the territory behind her, the specific skills that years of embedded learning have developed, the social relationships that provide her back connection to the world she knows, the stories of previous explorers that tell her something about what going into the unknown is like and how it can be survived. She does not know what is ahead. This is genuinely true. No system of knowledge she has access to tells her what the next valley looks like, or whether the river she can see in the middle distance will have potable water or prey animals. She will find out by going. She will learn the new territory by moving through it, by reading it with the ecological intelligence she carries, by surviving the mistakes that learning always involves. Ancient humans explored the world this way, across hundreds of thousands of years, across every major landmass, across stretches of open ocean that had never been crossed by any creature that walked on two legs, with nothing but the specific cognitive capabilities that evolution had built, the accumulated knowledge that communities had transmitted, and the specific forward-pulling curiosity that is one of the most distinctively human characteristics our species has ever expressed. They found everything. They mapped it in their minds. They transmitted what they found to the people who came after. And the descendants of every single exploration event, the specific crossing, the specific valley entered, the specific coastline followed to its end, are alive today, carrying in their genomes the specific genetic signatures of those specific ancient journeys, including you. Somewhere in your ancestry, someone took a step forward into the unknown, and everything that came after, including this moment, followed from that step.